Okay, my friends, here we are on phase 2 of this little project, this little sleep project, just basically working on using questions from the text to help us kind of key in and read the text carefully and figure out answers to the questions. And in answering the questions, we'll hope to understand the reading very clearly. So that's the idea. So let's work on this phase 2. I'm going to start it with you together, and then I'm going to just do one and then leave you to the rest. So I'm going to load back up my my Google slide. Hopefully everybody did phase 1. If you didn't do this yet, stop this, go back and do phase 1 first. Phase 1, we just created the outline, right? So what I want to do is phase 2. I want to focus on this very first section, which was biological rhythms and sleep. And the question we're focusing on is, how do our biological rhythms influence our daily functioning and our sleep and our dreams? And really, we're not going to get much into the dreams at this part, but it's just really more basic. We already found the key words. The only key word that was in this section was the circadian rhythm. So now I'm going to go ahead and open up the reading, which you can just click right here, online ePacket reading. It's also back here, online ePacket reading. It'll be around. So, and then we're going to skip to the part where we left off. So we got to roll down a little bit. Remember, this first section you're going to do later. So here we are, sleep and dreams. So you're going to read that little first intro part first, maybe highlight a few things. And I wonder if you could even highlight. I think if you open this up in Adobe Reader, you might even be able to highlight things. But I'm just going to go ahead and blow it up a little bit and just kind of start to read it out loud. This is kind of like me thinking out loud how I'm going to attack this. This is the question I'm focusing on in this reading. How do our biological rhythms influence our functions, our daily functioning, what we do each day? So I'm just going to start to read it. Like the ocean, life has its rhythmic tides. Over varying time periods, our bodies fluctuate, and then with them, our minds, right? As your body gets sleepy, your mind gets sleepy. Let's look more closely at 2 of those biological rhythms, our 24-hour biological clock and our 90-minute sleep cycle. So we're going to start with the biological clock, the circadian rhythm. The rhythm of the day parallels the rhythm of life, from our waking at a new day's birth to our nightly return to what Shakespeare would call death's counterfeit. Our bodies roughly synchronize with the 24-hour cycle of day and night through a biological clock called their circadian rhythm. Now, since that's bold, remember that's a key word. We already identified that, so we're going to definitely clue in on this. So the circadian rhythm is a 24-hour cycle of day and night, right? It's a biological rhythm inside our body. From the Latin word circa, which means about, and diem, day, about the day. So what happens, right? This question is like we want to describe how this rhythm is influencing us, and we want to describe the rhythm itself first. How does it work? So body temperature rises as morning approaches. It peaks during the day and it dips for a time in early afternoon, when many people take siestas. And then it begins to drop again before we go to sleep. So that's the first thing we want to make a note of that maybe. If you have a paper copy, you might highlight that part right there. Or if you can on Adobe Reader, highlight that. I'm not sure if you can do that and save it. I should test that. I've got mine open in Chrome, so I can't do it in Chrome, I know for sure. So maybe I will just go over and make a quick note. So I'm going to go to the second slide. This is where I'm going to start to answer this question. So the first thing I'm going to say is, well, the circadian rhythm, if I can remember how to spell it, is a 24-hour, roughly 24-hour biological cycle. So what's happening in that cycle? Well, the first thing we know is, we'll make a little bullet, is temperature, body temperature changes. Cooler equals sleepy. Warmer wakes us up. Right? So as the morning approaches, the body starts to warm up. And then we said we were the warmest in the middle of the day. And then, we had a little dip in the afternoon, maybe, where people tend to get a little sleepy, and then it begins to drop again before you go to sleep. So that's one thing we know. Now, thinking is sharpest and memory is most accurate when we are at our daily peak in our circadian arousal. Pulling an all-nighter, we may feel groggiest about 4 a.m., but then we may get a second wind. Okay. Bright light in the morning tweaks the circadian clock by activating light-sensitive retinal proteins. So that's a key thing to me. That's describing how this works. So the bright light, the lights against our retina is what's triggering this rhythm. These proteins control the circadian clock by triggering signals to the brain's suprachiasmatic nucleus, SCN. Now, notice they did not bold that, so that's telling me it's not like super important for us to memorize that. Just something to know. It's, some people are more interested. It's going to be more science stuff. And it describes there are a pair of grains of grain of rice-sized 20,000 cell clusters in the hypothalamus. The SCN does its job in part by causing the brain's pineal gland to decrease its production of the sleep-inducing hormone melatonin in the morning, or it increases it in the evening. Now that makes sense, and I know in my own experience, I've actually taken melatonin once in a while to help myself sleep. So your brain is producing a little bit more of it in the evening time, and it knows it's evening because of the light. So I'm going to make a note of that. Bright light against the retina. Maybe just copy and paste it, or we could just summarize it. Bright light against the retina. And hopefully everybody knows what the retina is. The retina. How do you spell that? Retina. Bright light against the retina triggers their circadian response. So that's a brief summary. I didn't go into all the SCN and all that other stuff. You could go a little more in depth if you wanted to. And I could say increasing melatonin at night, or in other words, when it's darker, and decreasing it in the morning as it starts to sense light. So that's kind of how it's happening, how the process works. And then what else we got? Then there's a little figure. It's going to be on the next page. It's going to show us bright light at night helps delay sleep, thus resetting our biological clock when we stay up late and sleep in on our weekends. So, that's saying if you have bright lights in your room, you're not, you're overriding nature. Sleep often eludes those who sleep till noon on Sunday and then go to bed just 11 hours later in preparation for the new work week. They are like New Yorkers whose biology is on California time. But what about North Americans who fly to Europe and who need to be up when their circadian rhythm cries sleep? Studies in the lab and with shift workers find that bright light, spending the next day outdoors, will help reset your biological clock. That's just a little tidbit. Curiously, given that our ancestors' body clocks were tuned to the rising and setting sun of the 24-hour day, many of today's young adults adopt something closer to a 25-hour day by staying up too late to get 8 hours of sleep. For this we can thank or blame Thomas Edison, inventor of the light bulbs. Being bathed in the light disrupts our 24-hour biological clock, and this helps explain why, until our later years, we must discipline ourselves to go to bed and force ourselves to get up. Most animals, too, when placed under unnatural constant illumination, will exceed a 24-hour day. Artificial light will delay our sleep. So that's something nice to know. And in here it explains a little bit more about the melatonin coming from the hypothalamus. So hopefully, let's go back to that. Basically answer, how do our biological rhythms influence our daily functioning and our sleep? Well, basically the light is how it happens. The light is the process. The light coming in against the retina. There's also they didn't really explain exactly how the body temperature triggers it, but that's a little bit part of it too. So that one, we hopefully got a better understanding now, and I would end it by making sure we describe the circadian rhythm. Do we need to define that? Well, basically we did it. Circadian rhythm is a 24-hour, and the melatonin is kind of the key to the whole thing, really. And then I guess the last thing is artificial light. It's kind of a no. Artificial light electrolytes can disrupt our natural rhythm. So that's something to keep in mind. So I guess that I would say is good enough. That's a good one. That one's pretty short. The next one I'm going to leave to you. It's going to be a lot longer. You've got 5 different key terms. So this is going to go through all the stages of sleep. So just take your time with it as you read through it. I would do that same kind of method. I would just kind of start to bullet things in the beginning. And then once you get the things bulleted, you may go back and be able to do a better job of kind of summarizing it. This is a little bit of a longer section. So make sure you just use each one of your key terms and work your way through it. And really you're just kind of using the slideshow to really do a good job of summarizing what you're reading and also really focusing in on answering this question. What is the biological rhythm of sleep? What are the different stages that we're going to go through? So I will say enough for now and good luck. And if you have any questions or need any help, let me know.